Okay. Next, we are going to think about the energy of light. Historically, the people use a different unit of energy for describing the light energy. And depending on the fields of study, such as physics and chemistry and optics. So um, you need to understand um, what's range of the energy you are dealing with in even in you were thinking about solid physics or optics or chemistry. So you can easily convert what range of energy you were thinking about. So here are the summaries of the energy conversion. Okay, so let's at first check up the energy per photon. Okay, so please stop the video for a while and then calculate the one photon energy in case you are using the wavelengths equal to 500 nanometer of light, which is green light. So please think about that. Okay, then let's check out. So energy equal Planck constant times frequency equal Planck constant, well, C upon lambda equal 6.6 times 10 to the minus 34 joule second times and 500 nanometer and 3.0. Okay, so which is equal almost like 4.0 to the minus 19 joule. Right, so this is the SI unit of energy, joule. So, but as you can see, every time you are using this unit, it's kind of trouble. Always you have to say some number with times 10 to the minus 19 or 10 to the minus 19. It's kind of trouble. But if you can use the electron volt, which is 1.6 times 10 to the minus 19 joule, which is very convenient if you are thinking about one photon energy, right? So you can convert the energy of the light to the electron volt. And this electron volt, and in my experience, the electron volt has been used for energy level of mostly solid physics. So many physics people usually use electron volt. And also now there's a very kind of convenient way to convert the wavelengths in nanometer and energy in electron volt. And this calculation is included in the after lecture exercise. So please try it for yourself. You can stop the video and you could calculate this one. So what I want to do is electron volt is given by some by the function of lambda in nanometer. So if you want to try, please stop the video and then calculate this. The answer is lambda nanometer. So this is a very convenient way to calculate the energy of light. For example, in this 500 nanometer of light, so you can just put 500 here. You can easily calculate the energy is actually 2.5 electron volt, or roughly. So very easy to calculate. So now move on. There's another type of the unit which is used, which is Kaiser, and this one is frequently used for infrared absorption. If you are a chemistry student, maybe you have an experience to measure the infrared absorption spectrum of the organic molecules. In this case, the horizontal axis is displayed with Kaiser. So this unit, as you can see, the number of the waves in per centimeter. So meaning that E is equal 10 to the 7, which is the 1 centimeter in nanometer, and from the nanometer. And after some calculation, and this one also included in the exercise, after lecture exercise. So which one? This is this can be converted like this. So it's almost like 8,000 times of electron volt. And the final unit I want to introduce is the kilojoule per mole, or kilocalorie per mole. And this one is often used for describing the bond energy or activation energy. And in my understanding, many chemistry people use this energy for light because it includes the mole. So you are thinking about the Avogadro number of the photon. So the number is can be kilojoule per mole equal n times h nu times 10 to the minus 3, because it has a kilojoule. So you could calculate this, and then this one can be calculated after the lecture exercise too, and you can obtain almost like 100 times the electron volt. And of course, if you want to change it to the calorie per mole, you just need to divide this by 4.2.